Okay. Okay, so thank you everyone for coming to Utkarsh's thesis defense. He's worked pretty hard on this project, so I'm excited that he gets to share it with everyone. So the way this is going to work is Utkarsh, you will get to present. While you're presenting, if we have a question, we'll either wait until you're done or we'll just raise our hands and ask it. Folks online, if you have a question, please paste it in the chat and I'll either relay it to Utkarsh or we'll do an open session afterwards. But feel free to post any questions or comments you have in the chat. I'll kind of be monitoring that too during your presentation. After he's done presenting, we have an open session where members of the public are allowed to ask you questions or give comments on your work. Once that's done, we're going to kick everyone who's not Utkarsh or who's not the committee. You get kicked out of the room. Then we get to interrogate Utkarsh in a private session. Then we'll kick Utkarsh out. We have a committee discussion, and then we bring Utkarsh back in to discuss decision takeaways, any other edits that you need to make. Sound good?
Yep.
Okay, great. Utkarsh, I will turn it over to you.
Okay, so all right, so before I begin, thank you everyone for being here, whether it be in person or Zoom. I really appreciate you guys taking the time out of your day to be here. Also, there's some snacks, so please free to help yourselves. So anyway, so I'm here to talk to you about today about what I've been working on over the last year, which is my thesis titled Reducing Cognitive Load in Healthcare, a Data-Driven Avatar System for Report Visualization and Doctor-Patient Interaction. That's a lot of fancy words to say. We really try to help out doctors in their day-to-day lives. And with that being said, so before I begin to talk to you about what we did, I kind of want you to think of yourself as a modern day oncologist. Okay, so in your day-to-day, you treat cancer. And so let's say you're scheduled to see 10 patients tomorrow, right? Now, what you're going to need to do is read up on all their health histories. So they could be coming to you for the last 1 month, 6 months, 1 year, decade. So cancer is something that doesn't just work on like words. You need proper scans, you need proper reports. So it's very important for you to read up on everything, especially if you don't know the patient or their history. Now, so we talked to doctors at the Mayo Clinic about this, and reading up on just one patient report can take them anywhere from 15 to 30 minutes based on how long the patient has had cancer and other factors. So best case scenario for these 10 patients, you have 2.5 hours of reading to do. That could be in one go, that could be like bits and pieces throughout the day, but you're going to need to do 2.5 hours of reading to just get a sense of where the patient's at and how their health has progressed. And now, once you've done all of that, you still have to do the checkup, you have to diagnose the patient, and then you have to cut down all the medical jargon and talk to the patients at their level. So basically layman, and you can't really say stuff like metastatic sites and stuff like that. Now modern day oncologists, they feel kind of like this person right here. This is Dr. Mike. He's 22 years old. He's starting to lose out his hair. We don't want that to happen. So we really wanted to help out Dr. Mike. So what we did was, again, we sat down with folks at the Mayo Clinic and we were like, let's write down what challenges they face on a day-to-day basis. Again, like we talked about, dozens, if not more, reports to go through, the reports and scans to go through for every single patient. Now, these reports can be long, uninteresting, and different from one another based on a variety of factors. Like not every doctor is going to write down stuff the same way. Maybe the clinic that you work at maybe doesn't have like a standard format. So, and it's like they're very verbose. Making inferences from them can be really hard. And while you're going through all these reports and scans, it's very important for you to document each and every anomaly. Missing even one or two can mean drastically different healthcare outcomes. So let's talk a bit more about what that means. So one thing that I want to discuss here is disease volume. So disease volume is the extent to which a disease has spread in a patient's body. So for example, prostate cancer, the treatment of prostate cancer depends on how many metastatic sites there are in a body. So a metastatic site is basically, so let's say a person X had a single tumor, and then that tumor spread to, let's say, 2 sites. So now they have essentially 3 tumors, but 2 new ones. So that's 2 metastatic sites. So any site that the cancer spreads to is known as a metastatic site. And if you have anywhere between 1 and 4 metastatic sites, that's one kind of treatment. And if you have more than 4, that's another kind of treatment. So just imagine you're going through like hundreds of these reports and scans. And now maybe you miss out on, you confuse between like a metastatic site and the original tumor, right? So that could be the difference between treatment A and B. And that could mean life or death, certainly in the case of cancer. So you really want to make sure that you're going through all these, and as a doctor, you're operating at 100% accuracy. So that's very important. And yeah, so now that we've talked about challenges, let's talk about what a potential solution could look like. And again, this might be a little obvious, but to do multiple things, you don't want to access multiple applications, right? You want everything all in one place. So that's kind of what this is. And now that solution also needs to summarize historical patient reports, right? Now, to make inferences, you obviously have to read through 100, let's say 100 reports, but it'd be great if a system or an application could do that for you accurately. And then once you're done summarizing, you need to be able to identify pain points. So for example, okay, stuff's happening, but does that correspond to my liver, my stomach, other places? So, and then you need to be able to figure out where to map that thing onto your body, right? So the system can tell you, oh, okay, something's wrong with the liver, but the system needs to point it to the liver per se. I don't know if this is the liver, but I'm trying to do my best here. And also, we need to check for hallucination in real time, right? So LLMs particular are notorious for making up stuff that doesn't exist from time to time. Now, and again, like we talked about cancer and treating cancer is something that needs to be 100% accurate. And if the doctor is being fed hallucinated information, that's basically death for a patient. And doctors are human too. They make mistakes, and so they need to be able to, let's say they make a mistake, right? So you come to me, I diagnose you and say, okay, something's wrong with your liver. And then you come back to me and you give me another information a month later, and I'm like, I diagnosed that something's wrong with this patient's liver, but now I think it could be their chest. So now, in a normal setting, you need to basically go back and fill out another form and do stuff like that to kind of erase their patient's history, their diagnosis, and kind of make it new again. So that's a lot of administrative work. And on top of that, this point right here, doctors, especially oncologists, cancer doctors, they look at patients' health progress over time. So, and then again, so what they usually do is they look at, let's say, X-rays here and there from like 6 years ago, and then today's, and then they're like, has this thing progressed or not? Again, you're doing a lot of inferencing, right? So we need a better way for them to be able to kind of compare how the disease has progressed. So these were the 7 bullet points, 7 key points that we kind of figured that any potential solution needed to do this apart from like reducing the cognitive load that the doctors have. And before I kind of begin into what we did, I quickly want to talk about what else is out there, what kind of research has been done on this, what the industry is doing. So there was a paper published in 2019 by the author Bergauer, and what they found out was avatar-based technology really improves transfer information, and it basically improves diagnostic confidence, which is basically the doctor agrees that, okay, I didn't go through all this information, I figured this out, but they're still confident, okay, I made the right diagnosis. And again, it reduces workload. And then you have Google's MedPalm, which is basically a general purpose LLM that Google has developed that you can ask it health related questions, and I believe it's up to 80 something percent accuracy with which it answers your questions. And then you have this is a startup. This is a French startup named Avatar Medical. Now they do this really cool thing. So they'll take your CT scans and your MRIs, and they'll make realistic 3D avatars out of them. So they're not full body avatars, but what they do is they create like a 3D model of your heart or your chest or your legs or something like that. So stuff like this does kind of happen out in the world, but what we did was we built upon all of them and kind of diversified that. So before I begin going into what we did, I want you to quickly take you through these 7 fun scans. So now we need to do all this, but how do you do that, right? Do you just give like one word answers? Do you like give a sentence? How do you actually reduce cognitive load? Now, as a person who's worked for a year in a database lab, the answer to me was kind of your database, right? So now the question comes in, how do you visualize this data? Do you go through reports? Do you chart do you make like bar charts, like pie charts? How do you display that information? And for thinking for about like 2 grand minutes, the answer was avatars. So James Cameron's $3 billion movie and this thesis they work on the same premise. We both use avatars. And to just kind of quickly take you through why data visualization usually works with reducing cognitive load is they help simplify complex information, they help you make rapid insights, significantly reduce errors, and this is a big one, they help you identify emerging trends, and we want to help them, the doctors particularly with this, improve their decision making. So this is kind of why we went the data visualization way, the avatar way. And so, what you see right in front of you is, this is an Indian news channel. They give you all information all at once. This is like, if you have some medical conditions, this could give you a seizure. Now, I don't want to make something that would make new patients. I wanted to reduce their count. So and a little bit about this. So why separation of concerns was a thing that was looked at. So for the front end of this application, we use React, and traditionally React is used to create single page applications, right? Now the choice was like, do I give everything in one page? No, I don't want something like this. So eventually it was decided that I would kind of divide everything into three separate web pages, all taking one or more of those 7 key points that we talked about right here.
So can I ask a question?
Yes, please.
You go back to like I use Indian news as an example of information overload.
Yep.
Like, was this a decision that you made by yourself, or did you like talk with doctors to make it, or like what was the process that you kind of used?
It was definitely collaborative, but as far as the doctors go, they didn't really have specific inputs of this goes on in one page, but they just knew like, we don't want everything all at once.
Yeah.
So it was then decided it should have multiple pages, but how many it should have. So
Okay.
There has to be like a balance, and I don't want to give out like 7.7 pages. That's too much. So that was kind of the thinking behind that.
Yeah.
Okay, so like any software engineering project goes, before you start building something, you spend a lot of time doing a lot of back and forth with your clients, creating Figma wireframes. So now that we've decided on we're going to build like a 3-page system, it was very important for the doctors to have something that looks kind of like their version of HMS, their healthcare management system, which is Epic. So they're like, we need something that kind of looks like Epic, and the very first page of that would kind of looks like, and in our application would also look like an Excel spreadsheet. So yeah, again, like the very first bullet point talks about everything everywhere at once. This page kind of signifies that you can add patients, you can modify them, make changes to their personal information if required. But again, this is now where the magic happens. It's basically a home page with the patient information on it. Now, this page would be kind of the breadwinner for the entire thing here. So I call this the avatar page. What it does is this bit right here is supposed to be a chatbot. You ask it questions based on whatever diagnosis you made or whatever patient came to you. The chatbot then goes and reads through these reports, and then it spits out information and then plots it over to the avatar right here on the right. So and then also this was supposed to allow people to doctors to be able to check for hallucination in real time. And we kind of did that. I'm excited to show you where we did it, but yeah, that's something that came
Are you
about.
showing it on this image?
N-
The hallucination
N-
kind of
no.
checking? Okay.
No, the idea initially was that a report would kind of pop up right here.
Mhm.
But you know, as things progress, we kind of shifted. And that so there's a screenshot and there's a video for that entire thing, but that's on the actual application page, not on here.
Have a question. So
Yes.
here, like the summarization based on the doctor dictated or doctor written reports, it's not directly based on the images or the metadata of the image, right?
So we're not using images like scans and stuff. We're operating solely on doctor generated reports.
Oh, okay, got it.
Like
So-
text reports.
Text reports, sorry, yes.
So it's like a Word document.
Yeah, it's like a Word document. And it has to ensure that it was HIPAA compliant, it was all anonymized. There was no personally identifiable
Oh.
information. So yeah. And then to kind of allow the doctors to basically compare patient health status over time, we kind of built this timeline page. So basically the idea was if the doctor is satisfied with what they see here, they would hit save, and then that avatar would kind of get stored in this timeline right here. So if they want, they can scroll across it, do whatever, and then they can select 2 random avatars of their choice, hit compare the 2, and then if they wanted to go back and let's say you're not satisfied, you know, I don't think there's something wrong with this person's name. Maybe there's something wrong with their crotch. You kind of hit this, kind of rerun the entire thing, save that, and then this would identify the crotch, kind of rewrite whatever diagnosis you made.
So it's meant to be quite flexible.
So I call it go back in time. I saw that in a movie once. I thought it sounded cool. But yeah, so that's enough talk about, you know, what it should look like and how we came across it. Let's just talk about the actual thing. So enter the system for navigating and analyzing patient events, or for any Harry Potter fans out there, Snape. So again, before I go actually take you through the walkthrough of the actual thing working, just to show that, you know, it kind of looks similar to what we came up with in Figma. This is what we had. This is the blueprint that we had, and this is kind of what we ended up with. So again, you click on the add button to add patients. You click on modify to modify them. And again, since this was a prototype, we're not taking too much information. This is just to show that the thing actually works. What we're really concerned with is their reports, not with their metadata, like, I don't know, age and weight and sex and stuff. So if you were to click on this floating button right here, you would be able to add a new patient, whatever details they have, upload their reports. And if you wanted to modify a patient, you would then again just click on one of these modify buttons right here and change stuff. And again, this is nothing fancy. This has been done 1,000 times over, but going back to what I call the bread and butter of the entire thing. The avatar page. So let's say you have a patient named Jack Reacher. She comes to you and she's like, doctor, I feel like there's something going on right over here, right? So you kind of have they've visited you 5 times before, and what you do is you kind of ask the system, what do you think is wrong with their liver? You think it could be something wrong with their liver, so that's why you ask it that. And then it kind of spits out some information. This is the response that it spits out. And right over here, it went through 4 reports. Maybe report 5 didn't have anything liver related, so that's why I didn't go through it. But in essence, and then it kind of highlights, you know, I went through all these reports, and this is the information that I'm using to kind of come to this conclusion. And to kind of quickly take you through everything. So this is the section that keeps all the patient reports, past reports. This is where you identify a real hallucination, check for hallucination in real time. You ask it questions. These are just saved prompts, there's nothing special here. And then this is where you get the actual responses. And this is the avatar, and we kind of identify pain points right over here. Now I'm going to take you guys through the entire, each and every one of these subsections, just to make sure we kind of go through everything. Again, these are just patient reports, all in one place, nothing too fancy here, but just to take you through what kind of reports we worked through. So as you can see, there's no personally identifiable information anywhere. There's no names, there's no email addresses, phone numbers. So you can't really figure out who it is. And this is just a doctor. Some doctors at the Mayo Clinic made these reports. They anonymized them, de identified them, sent them to us to work with. And this is kind of what a sample response looks like. So we asked it about the liver, and then it says maybe you have some fatty filtration, stuff like that, whatever it thinks is right. But other than the response, there's like some other elements to it too. So if you were to click, on this, it would reveal more information about what the response is, how it came across it. And this is kind of what it looks like. So the tag locations, you talked about the liver, and it says there may be some fatty infiltration going on. So it tags the information, you know, something's wrong with your liver. It tells you what reports it referenced to reach that conclusion right here. And it also keeps track of what you asked it. So kind of like your general chat GPT, but changed, like modified to suit our needs. And this is just the patient snippet, just a quick glance through of who they are, when they last visited, when they're next going to visit you. And this is a sample avatar. So for example, you know, you ask it a question and then it comes across, you know, there's two things wrong with this patient. Now, what we do is, if there's multiple tagged locations, for example, liver, chest, what we do is, from this response, we extract what's the liver related information and what's chest related. And then we map those accordingly. We don't want chest related information to be in the liver. That's just more cognitive load. We're trying to avoid exactly that. This is just for you to play around with. This was a side quest. You can kind of rotate the avatar, move it around. There's not just a side quest. I'm going to talk more about what this is and how in the future we can kind of improve upon it. But in a sense, this is to just move the avatar around, and this is to reset it if you like. And then comes the timeline page again. However many times people have come to you, you kind of uh, make the diagnosis, save their avatars if you're satisfied with them. Everything that you save goes on into this timeline page, and it goes from left to right. So the very first visit is on the left, the very last is on the right. Now, if you want, you can compare two avatars. You would select those. So we only allow you to compare two. You can very easily write code to write compare 3, 4. But again, when you compare, kind of compare two. So yeah, and when you compare, this is kind of what it looks like. Everything goes in the background, and this is what you end up with. So you can kind of just hover your mouse around and see, what's different with this person, and what's not. So you can kind of compare in real time. Again, it's very important to note the system is not making comparisons for you. We want the doctors to firmly be in control of their diagnosis. And so, I talked about going back in time. So, for example, you're not happy with, this chest diagnosis that you made. You would then kind of click on it and then go back in time to a page that looks the same, basically. And then you would ask it a different question or whatever. And then once you're satisfied with that, you would click save again, and then it would kind of override it right here. So, for example, from chest, if it goes to knee, this dot would be replaced by this. Again, that's all in the walkthrough video. So yeah, that's basically all the screenshots per se. Now let's go through the actual thing. So again, this is just I tested on like a lot of fake patients. So right now, let's just add a patient. Let's just assume their name's Anne Harley, whatever. And then this is just basically adding in patients. So I didn't want my actual PC's folder structure out there, so that's not in the YouTube video. But I basically select these files from my PC and then I submit those. And
What kind of file types does it support?
docs.
Docs,
Or
okay.
docs. And again, so you're trying to diagnose Anne Harley, so you would kind of go right here. And there's like multiple reports for Anne Harley. And let's say you want to ask a broad question, right? What's wrong with the patient? So go ahead and you kind of just, ask it, see what happens. And what the system does is, again, it goes through all the reports and it comes up with a response. So as you can see, it thinks a lot of stuff is wrong with this patient in just 10 reports. I seriously hope she gets well soon, but this is kind of what a general broad question like this, would kind of give you. Right.
So how's the speed?
So yeah.
Sometimes slow?
So yes, it really starts to get slow when you hit the 25 range.
Okay.
It's not considerably slow, but it's sometimes it can also be down to like just, I don't know, the API's response. I have no control over it. But yeah, but obviously the more the reports, the more the text that has to rifle through, slower it kind of gets. And yeah, on the bottom there, you can kind of just see in real time if the information that kind of give out to you at the top, if that was correct or not. And now, I don't recommend asking it general questions. It's too broad, and that tends to amplify the system's ability to hallucinate. Just like a general chat GPT, a weak prompt will generate like a loose response. But like if you ask it stuff like, take a role of this person, you take this persona and then ask me questions. So yeah, so now let's just ask it a more specific question. So for example, we ask it, tell me about the patient's kidneys. And let's see what it spits out. And yeah, so for example, it just rifled through a lot of information much quicker in this case. Again, it had to go through 10 reports. So it just sometimes just depends on what the API is feeling. Right, so what's this time? And now it kind of you can kind of just go ahead and hover over it, see if this information aligns with this and this. And if you're satisfied, you can go ahead and click save. So and then you would click this button right here to go to the timeline. And so for now, there's just one thing there. She just visited you. You just checked up on her once. Now, let's say Anne Harley's back. And she says she feels some sort of discomfort, maybe around the stomach area. And based on whatever she told you, you feel like, you know, something might be wrong with her bowels. So let's see what the system has to say about that. And again, this is kind of what we just saw, but just for a different prompt. It spits out information. It tells you more stuff about its findings right here. And then right at the left, you can verify for hallucination in real time. Just a quick note kind of about that. So yeah, we just kind of just save this to the timeline.
I have a question. So for
Yeah.
the left part, that part is like those for each report, the corresponding words are highlighted.
Yeah.
So how did you implement that part?
So it rifles through all the reports and I gave it like a very specific prompt and then I extract highlighted text using JavaScript functions. And then I plot those.
So
over there.
that's not produced by LM. It's based on some text indexing, searching functionality.
That's generated by the LLM.
Oh,
It's literally telling you.
Oh.
It's literally telling you how it gave this and how it gave this. So I just kind of just highlight that in an MUI paper.
So you have like a follow-up prompt that's like, here's the response. Tell me what parts of the report.
Yeah.
Basically, like you took that response from.
Yep.
Okay.
And okay, so you've saved this thing to the timeline as well. And now she comes back to you and she's like, doctor, I don't know, I'm still, you diagnosed her, you gave her medication, and she's like, doctor, I still feel some discomfort right here. So you kind of just, okay, you can kind of compare these two if you like as well. Now she's back and she's like, doctor, I still feel some discomfort right here. And you're like, maybe I misdiagnosed her. So what you would kind of do is you would click on this thing right here, the very last diagnosis that you made, the last avatar that you saved. And it will land you right back over here. And now you're like, I don't know, maybe something's wrong with her watch. So you ask it that again. So I want you to kind of focus on this location right here. Kind of shifts. So it kind of overrides the stuff. And then if you're satisfied, you can go ahead and kind of save this to the timeline, and just to verify, you can go back on it and now stuff's changed. So that's kind of what it was in motion, but the doctors, they use it for multiple reports. And so this was basically a simplified version of the thing with list reports. Well, now that we kind of know what it does, what it looks like, let's talk a little bit about system flow and again, a simplified version. So again, the very first thing that you do, you log onto the application and then you store stuff to the database, which in our case is Google's Firebase. Simple enough, there's nothing fancy going on here, just uploading stuff to the database. So now this is kind of for the where pages two, the avatar page and the timeline page, this is how they work. So in the avatar page, you ask it a particular question. And for example, you ask it like, what's wrong with this person's liver? And then the LLM then goes through all the concerned reports, only those reports that it needs to go through. And then it kind of generates tailored responses and then it plots them on the avatar. And then you would kind of, so now when you save stuff to the timeline, to the doctors, it's only saving the avatar, but that's not how it kind of takes place. It's not just the avatar that we're saving. So I talked just a little bit about React, the front-end library that we used. So React focuses a lot on like components and like their states. So when the doctor hits save, I save each and every component state at that particular time. All that goes to the Firebase, and when you're on the timeline page and when you want to change stuff back, when you click on it, I take back all those saved states and use those to recreate the page that it was before when you saved it. So kind of going back in time. So this is kind of what it is, simplified. I did some tests to see how accurate this was, if this was even worthy of like presenting to you guys. So before I kind of talk about all this, let me quickly take you through the way that it was tested. So I did batch testing in two types. So it was reports 1 to 12 and then 13 to 25. Both of them gave similar responses. So as such, there was no deviation with the number of reports per se, up to 25 at least. We can put it on a production scale and see what happens then, but for up to 25, there's no particular deviations. So we asked it 3 types of questions. So broad questions. So you saw this in the video, what's wrong with the patient? It gave accurate responses about 95% of the time. We asked it very specific questions. What's the size of knee enlargement in the lymph nodes in report 3? It's 99%, but I didn't see it say something wrong here a single time. So that's very close to 100. And when I asked it to compare stuff between reports, that's when it kind of wobbles. So we discussed all that, but let me take you through more slides. So when you ask it really broad questions like what's wrong with the report, and let's say the correct answer should have been the chest, the crotch, the liver, the kidney. It kind of gives you incorrect responses or hallucinations in 2 separate categories. It either misses something. So for example, maybe it missed crotch or something else. That happens in 99% cases. Very rarely does it just make stuff up.
Percentage of wrong cases, like
Yes.
it's predicted cases.
Yeah. And just 1% of cases, it spits out just something random. Foot. There was nothing wrong with the foot, but it just said it. So again, this is really rare. Most of the time, it just misses stuff.
And so, but you're able to kind of,
You ask it.
the idea is that the doctor would be able to verify that in the reports, and
Yeah.
they would notice
Yeah.
that it's referencing something that doesn't actually.
Yeah.
Okay.
And usually you just ask it the same thing twice and it gives you the right response.
Well, but then it might be 1 in 1,000 cases that it still might mess up.
Yes. Yeah. The probability is there. Yeah.
Okay.
And so again, specific questions, it was bang on. I didn't see a single case in multiple testings where it says something wrong. But here's where the accuracy kind of gets shoddy. So let's just discuss those cases. So when I ask it to compare stuff, so let's say the doctors accurately write down how big of an enlargement there was in the lymph nodes in reports 3 and 4. So if you type down and then you ask it, are the patient's lymph nodes in a worse condition in reports 3 or 4? Now, this is worse. That's a bigger enlargement. So 95% of the time, it gives you the accurate information. It says report 4. The rest of the time, it tells you, it seems like it's report 4, but more context could be needed. You need to talk to a medical professional. So I don't count that as accurate, but it is still a desired output. It's nudging in the right direction, and it's telling you maybe go ask a doctor. And then when it's and then I tried to compare it with an integer value and a string, or semantics. So asking the same question, but where there was 1.4 centimeters before, it's the word slightly. It's really bad. It gave accurate responses only about 5% of the time. And the majority of the cases, the reasoning that it gave was there's mildly enlarged lymph nodes in report 3 versus slightly enlarged nodes in lymph 4. Mildly was not in the report. It just made it up. That's something that maybe needs to be looked into. But this is an interesting find that I saw. So it just it comes to a conclusion, and it just kind of justifies it. And it kept saying mildly. That's the
Yeah.
number that.
What GPT what LLM were you testing? ChatGPT or something else?
ChatGPT.
Okay. Like 3.5 or 4?
4.
Okay.
And then this case is kind of like comparing two integers, 1.2 and 1.4, but it's semantics. So if you use the word slightly and severely, so severely is worse than slightly. Again, it gives off about in 94% of cases, it tells you that's correct. And in the other cases, it just usually gives you answers like seems like report 4, but you might want to talk to a medical professional. So the only case where it hallucinates is stuff like this. And well, we build this for the doctors. Ultimately, it really matters what they think. And so they thought some good things about the application. So Snape does help reduce cognitive load. They did report that it helped that they didn't have to go through everything, read through everything to make inferences, and that it gave out information mostly accurately. And the pre-patient checkup time, the very first slide that we talked about, 15 to 30 minutes, that time they reported that it was cut down by about 30-35%. And they really like that you can check for hallucination in real time. It helps keep track of disease trajectory, and the doctors still feel in control of their diagnosis. So this is very important. This tool was built as a suggestive thing, not a predictive thing or anything. I believe the healthcare should remain firmly in the hands of people, humans, doctors. So they agree with that kind of vision. And so two bad things about this is that they think is the avatars are two-dimensional. Now, I agree. So for example, if there's something wrong in this area and there's something wrong in this area, 2D in a 2D avatar, you can't really figure that out. So it would be much better if the avatars were 3D, which would be, I talk more about that in later slides. But yeah, it'd be better if the avatars were 2D, and it'd be better if those 3D avatars were layered. So, something in the bone, something in the muscle tissue, outer skin, stuff like that. And as we just talked about, the LLMs, they just hallucinate every now and then. So that 5% case was kind of bad, but yeah, that's another drawback. One thing that they kind of didn't like. But again, this was not as big of an issue.
Yeah, I mean, you're kind of at the mercy of the LLM in terms of like.
Yeah, you're also at the mercy of the LLM and the report. So if you follow like standard procedures, if you actually write down the measurements, it gives you correct responses.
Okay.
But if you're like slightly that's when it tends to hallucinate.
I see.
So it's kind of a two-way street. And sorry. Right. And just to conclude, There was indeed considerable reduction in healthcare workers' cognitive load. Doctors reported that there was a 35 time reduction for pre-health checkups. So anything, if it took them 15 to 30 minutes, it took them like somewhere between 10 to 20. And I just talked about this. Snape's AI is purely suggestive, keeps healthcare firmly in the hands of the doctors. And the application remains highly scalable and ripe for improvements. So all the tools that were used, especially it was Firebase, it's a cloud-based service. It's kind of a pay-as-you-go kind of thing. So if you wanted to go like full-scale production, you can just go, you just have to pay. So, and as far as ripe for improvement goes, that's the perfect segue to future work. So you just saw that there's like accuracy stuff happening here. So it'd be better if we could build a more efficient LLM that was trained on hundreds of these patient reports. Again, anonymizing them and de-identifying them can be an issue, but a more efficient LLM is definitely the way to go if you want to improve accuracy. And developing 3D avatars. So, you know, based on the patient's sex, weight, height, and age and other stuff, you want to build like accurate avatars. So, you know, for example, you just saw Jack Reacher, a male person had a female avatar. You don't want that, right? Based on their age, their sex, you want different avatars. So, you know, the doctors can also keep track of maybe their BMI, some intuitive stuff. And we want to incorporate a predictive AI tool at the timeline page. So basically, when you have all these avatars from A through Z, we want a tool there that kind of tells the doctors, hey, this is where I think this person's health is heading towards. Maybe you want to think in that direction, maybe do something preventative or something like that. And then, so what we don't use in this tool right now is patient scans like MRIs and CT scans and stuff. So we want to build a tool that can kind of just take those scans and then just build patient reports right out of them. Because sometimes what happens is maybe, you know, you have to wait for the radiologist to kind of go through stuff, and that can be sort of a roadblock in creating of like patient reports. So we want to cut that time down. And thank you.
Great.
That was my presentation. I hope I was able to convey what I was trying to. Thank you very much. If there's any questions from the audience, I'll be.
Okay, so you know what? I think I'm just going to let everyone unmute themselves if they want. Okay, so if you're in the audience, so since I trust everyone in here, let me stop the recording too.